Okay, so in this video I'm going to go over linear versus nonlinear systems, which is what the professor covered in class. So the way we're going to do this is we're going to check if the system is linear, and if it is not, then we assume it's nonlinear. Sounds easy, but it's a little more complicated. So to check if a system is linear, check if linear, it has to follow the law of superposition. Which is essentially when you do a x1 of t plus b x2 of t as your input, and you feed it into a system, feed it to any system, you'll get back a y1 of t plus b y2 of t. And you could represent this in an equation, and I like to follow this equation. It's much more simple, which is h of a x1 t plus b x2 t, which is equal to a h of x1 of t plus b h of x2 of t. And this left hand side of the equation is going to represent you following the system once, because there's a one squiggly bracket here and one squiggly bracket here. So that represents you applying the system once on the left hand side, and on the right hand side you kind of apply the system twice to two separate terms, once here and once here, because there's two squiggly brackets. And if they're equal, then the system is linear. This will be much better to explain with an example, so I'll put this on the side. So let's say for this example, y of t is equal to x of t minus t naught. So what we're going to do is we're just going to follow the left hand side of the equation, and then we're going to follow the right hand side of the equation and check if they're equal, and then you're good. If they're equal, they're linear. If they're not, then it's not linear. So how do we apply it? Well, we'll start with writing the equation. H of squiggly bracket a of x1 t plus b of x2 t is equal to, so these squiggly brackets, this essentially means right here that you apply the system to this, and we can see that the system, what it's doing, it is changing x of t to x of t minus t naught. So it's replacing t for t minus t naught. So anytime you see a t, it gets replaced with t minus t naught. Okay. Just want to get that in your head. So we have a x1, and we'll get t minus t naught. We're we're substituting t for t minus t naught plus b x2 of t minus t naught, just replacing it. And this is just, if you're wondering, oh, where did this ax1t come from and bx2t minus t naught come from? Where did this come from, these two? Well, I'm just following the equation to check if it's linear, okay? It's just simple as that. You're just following an equation. So now we're going to do the right hand side of the equation, and I'll do it step by step. I'll start with this term here. So we have a h of x1 of t, and that is equal to, so we're going to apply our system. We're going to first write a, and then that gets multiplied to the system, which is, we established before, it turns into, for every t you see, it turns to t minus t naught, which will give you x1 of t minus t naught and now we'll do the other term, b of h and it's x of 2t, and I'm not good at writing this quickly, but it's like this, right? It's supposed to be something like that, but I rush it. Okay, so it's that, and for every, so you're gonna write b, I'm just moving over the b, and then I'm gonna apply, I'm just moving over the b, and then this means to apply the system to x2 of t, yeah, so apply the system and you'll get x2, and then what does the system do? It replaces t with t minus t naught, and dirty substitutes the whole thing, so get t minus t naught, and that's it. So you could obviously just rewrite it as a x1 t minus t naught is equal to b x2 t minus t naught, and now when we add these two together, the equations, because as you remember before, it's like this, you'll just get these two added together. They're added together, okay? So let's call this equation 1. I'll just write it out. So we have this formula, and we applied the left hand side and the right hand side. This was the left hand side, and we applied it over here, and we got this. And then we applied the right hand side here, and we got this after applying it. And we applied the right hand side over here, and we got this as a result from applying the system to each term. And we could clearly see that they're equal to each other. So this is equal to this, and this term is equal to that term, and the equations are basically equal to each other. So if I also rewrite it, it'd be ax1 of t minus t naught plus bx2 t minus t naught is equal to, and I'm just writing this equation, ax1 t minus t naught plus bx2 t minus t naught. Okay, now I'm going to do another example much faster. Oh yeah, before I move to the other example, so forgot to mention, since the equation upheld, since the equation worked and they were equal to each other, it follows the law of superposition. So that means example 1 was linear. And to do the next example, so this is an example. Let's apply the equation. Let's do the left hand side first of the equation. So I'm just going to write h of a x1t, just applying the equation here, plus bx2t, doing nothing fancy, just writing the equation. And just to remind you again, this means I'm applying the system to anything in the bracket, which is the input. This is obviously the input, x of t. And that is equal to, so now I'm going to apply this and this to the system. So we could see that for every x of t for this system, or x of n, sorry, we're dealing with discrete time, so for every x of n you see in the system, you'll get, it gives you a x of n, and this is a u. It gives you an x of n, and then plus a u of n, plus 1. So that's what it does. And for the left-hand side, we're applying the system once. So we have a x1 of n plus b x2 of n, and we're going to apply the system once, and we'll get plus u of n plus 1. That's pretty much what it does. It just adds a u of n plus 1. And that's the right hand side. We'll call this equation 1. And let's do the, did I say left hand? I can't remember what I said, but this is the left hand side. And let's do the right hand side now. So it's a h of x1t, and I'm just going to do in one line, plus b h of x2t. So we're going to apply the system twice in this equation, but on two separate terms. The first term being this, and then there's an addition sign, and the next term being that. So we're going to get a of, and I keep writing t, it should be n. My bad. So we're going to get a of x1 of n, and we're going to apply our system, which adds a u of n plus 1, plus u of n plus 1. So I do it once because the equation tells me to. This means to apply the system, what I'm highlighting. And then I'll do it again, plus b x2 of n. And now I have to apply the system again. Just write it like this. Oh, it's getting messy. Okay. Plus b of x of n plus u of n plus 1. You get the idea. We applied it twice because we have the h of and the squiggly brackets. That means we apply the system. So that's why we applied it again. And we can clearly see after, I'm going to call this equation 2. Equation 1 does not equal equation 2. So this system is not linear or non-linear. And also a quick tip, if your system is just scaling anything, so if your system is just scaling, then you can automatically assume it's linear. But the best way to check is to just do this equation right here and just do the left hand side, do the right hand side, and you're pretty much golden. If they're equal, then it's linear. If they're not, then it's non-linear.